Hey everyone, I'm Jack Rusk, CEO and co-founder of C.Scale, and I'm really excited to talk to you today about how C.Scale is supporting architects, engineers, contractors, and practitioners across the built environment in designing and delivering sustainable, low-carbon buildings. Many people these days are hearing about us through our high-profile partnerships with Autodesk Forma and Schneider Electric, but we also have over 6,000 users in our open access tool, including partnerships with some of the leading architecture firms in North America. Across this wide spectrum of users, our goal is to provide them with more data in less time so that they can make better decisions about their projects. We do this by leveraging our proprietary data models that fill in data gaps early in the design process, when data is typically scarce, but the biggest decisions are being made. These early analyses establish the goals and ambitions and help teams figure out what's possible so that they can continue through to the end of the process, connecting high-level ambitions with the nitty-gritty necessary to deliver sustainable buildings. I'm just going to go ahead and assume that you're here because you're interested, like our other users, in integrating whole life decarbonization into your existing workflows. So let's get started. I already have an account, so my email address appears here. But if you don't have an account yet, no worries. They're free to create. Just click the sign up link. You'll enter some information. A prompt will go to your email address to confirm that you are indeed a human. Then you can sign in like I'm about to here, entering my email address and my password. And that brings you first to this homepage, which lists all the projects you've previously modeled. Now, if it's your first time logging in, you won't see any projects. That's okay. You can click the New Project button, and that's what I'm going to do here as well. So I'll model a new project and walk through some of the common uses of C.Scale as it relates to new construction. I'll put out another video soon that talks through retrofits and approaches to retrofits in C.Scale. So this will be a school in San Francisco. I'll use the imperial unit system so we can work in feet. The project will be completed in 2025 in the United States, and the postal code in San Francisco is 94111. The primary use of this building is a K-12 school. Say there's 3 above ground floors and a total area of around 60,000 square feet. Really kind of broad brush description of the building, but we can always define our project in more detail once we've created it. There's the option, if you're just getting started, to auto-generate some decarbonization scenarios. I'm going to turn that off so we can create them manually and demonstrate the process by which you create new scenarios. Great, with just this data entered, I will create the project. This brings me immediately to this page, which gives me sort of everything I need to know about the project in one view. I have project information in the upper left, scenarios in the lower left, visualizations and graphics in the center, and information about a specific scenario on the right-hand side. Note that when you have the baseline selected, you're going to get this edit baseline cover on the scenario editing. This is to ensure later in the process that you're not accidentally editing the baseline, because that's going to affect all the calculations of reductions against the baseline for other scenarios. We'll get more into that shortly. First, I'll explore some of the figures that are available in the center. So for this business as usual baseline, we have emissions over time. This is a 30-year analysis. You can look at emissions by scope category, energy use, structure, enclosure, interiors, etc. By life cycle stage, so raw material extraction, construction, in-use emissions, replacement emissions, and energy use. Or get a sort of summary of these data so that you can get some direct readouts about the EUI, the embodied carbon intensity, et cetera, et cetera. I'll go to the life cycle stages first, and you see that the 30-year analysis is A1 to B6, but I'm going to edit some of these project settings. So the first thing I'm going to do is I'm going to turn this actually into a 60-year analysis. And the first thing I'm going to see is that adds some additional life cycle phases. So now I have C and D phases present. I'll continue doing some editing here. You can see I can toggle on or off some phases or scope. You can see that I can change again here to the metric system if that's my preference. You can't edit the country once the project is created, but you can change the postal code. You can add a secondary use to the building. So say this is mostly a K-12 school, but some I want to describe explicitly as a library. Say the library is about 40% of the building. This will do things like, say, shift the energy use intensity estimate, because I can also say that, say, part of this is a data center. And this obviously has a much higher energy use and structural needs from a K-12 school, but I'll ignore that for now. This is just a K-12 school. So I'm happy with the 60-year analysis. And I see immediately, looking at these life cycle stages, that B6 energy use emissions are the lion's share of emissions over 60 years. This is also confirmed by this figure, where I see these emissions accumulating over time in this cumulative view. And these energy emissions are the lion's share by the time I get to year 60. So if I'm a designer on this project, or if I'm in pre-construction as a contractor, let's see what we can do about this to reduce the emissions profile of the building. So I'll create a new scenario, and I'll call this operational carbon reduction, and I'll try to spell reduction correctly. Great, so that creates a new scenario you see that pops up over there. I'll collapse all these tabs so I can get a better view of everything involved. Let's poke around this energy use tab. So this one governs, go figure, carbon reduction measures associated with the energy use in the building. Let's add some strategies. First off, I see here when I look at this data that fossil fuel emissions are a major contributor to this building's energy use. Well, in San Francisco, it's actually required that the building's all electric. So I electrify the building and I see that difference. I can also set an EUI target. I get 66. This comes directly from Zero Tool, which is the energy use intensity baselining tool that's used by the AIA DDX for the 2030 commitment. And I'll input instead, say, 30 as an EUI target on this building. Amazing. I feel much better about myself now. I've reduced these emissions in year 60 by probably about 50%, just with two measures, electrifying the building and changing the EUI target. You can see that when I make these changes to this to the carbon reduction strategies, I get these little reset. So that's if I make a change, say I commit to a clean power purchase, the client disagrees. Well, I can easily reset that to the baseline, just sort of reset it to, again, the choices I've made in this baseline scenario. So I'm pretty happy with these operational carbon reductions. And if I go to something now like scope categories, I see that energy use emissions are sort of in range of other categories, and other hotspots like, go figure, building structure, start to emerge. Well, this suggests to me that there's something to be done about embodied carbon in this building. So I'll go back to this view, and I'm going to make a new scenario. And I'm going to call this one embodied carbon reduction. Create that scenario. It'll come in immediately, just matching the baseline. That's all good. I'll start with the structure, and let's try some stuff out. Say this is a mass timber building instead of a concrete building. You see a reduction in emissions in year 1. I'll ensure that the concrete I use in this building is sourced from local, low-carbon concrete suppliers. The concrete emission profile that we use in this tool is really heavily localized. So you get a very different profile of concrete, say, for instance, in San Francisco, where I'm modeling now, versus Los Angeles or Miami, or Norfolk, Virginia. Same with the steel. There's always steel in mass timber buildings. And again, the timber, I'll say best practices. I'm also going to ensure that the timber is responsibly sourced by ensuring it is a transparent and traceable supply chain, and that the source forest has a growing carbon stock. You see how that resets the figure, and these claims allow me to count the carbon sequestration benefit, carbon storage benefit in the timber in the building. So great. But really, low embodied carbon design might start with the structure, but it doesn't end there. There's lots of other opportunities to look at the hotspots. So I see, if I divvy it up by, I see structure, enclosure, and it looks like the replacement emissions in these interiors are relatively high. So I'll go to interiors, and I will specify a kind of a best practices fit out. And I'll make sure the service life of that fit out is longer, 20 years instead of 15. And you see, great, I've sort of eliminated that hotspot with these choices. If you're curious what a best practices fit out mean, you can look at the documentation that's linked in all of these circled eyes. You can also see directly the carbon intensity value that's assumed in the tool. This will help in target setting as you transition into later project phases. So now that I've created these two scenarios, let's compare them. I'll do that by going to compare scenarios on top, and then I can look at the scenarios against each other. These eyes control whether the visibility of scenarios, so I'm going to turn off the business as usual scenario and just look at the embodied carbon reduction and operational carbon reduction scenario compared to each other. And I see sort of what I expect. Embodied carbon reduction scenario has much lower emissions in year 0. Operational carbon reduction scenario has much lower emissions in year 60. And the trade-off point, which is always interesting to look at, is a little after 2030, maybe 2033 or 2034. These trade-off points are really interesting to clients often because they're trying to understand, right, what scenarios best match their stated climate ambitions. And they might have a decarbonization target by 2030 or 2040 or 2050. So the choice of scenario here affects how this project stacks up against their ambitions. But really, ultimately, the other thing I'm learning here is that just operational carbon reductions and just embodied carbon reductions alone don't really do what I want them to do. So instead, I'm going to target a scenario that combines both. So I'm going to start with the embodied carbon reduction scenario I just created. I'm going to duplicate this scenario and get this copy. First, let's rename that too, actually, and let's call it whole life decarbonization. And I'll take that embodied carbon scenario I just copied, and I will add to it electrification and the same EUI target I set previously. So they're right combining the operational and the embodied carbon reduction strategies for this whole life decarbonization plan. And all of a sudden, things are looking a lot better. I see a substantial reduction of carbon in year 1 and substantially lower carbon emissions versus either scenario in year 60. This is looking great. Because I like this scenario, I'm going to set it as the target scenario. And when other people look at this project or I'm sharing something out, this helps remember, right, that this is the scenario that I'm most excited about, that I'm going to advance to the next phase of design and share with the client. We'll leave it there for this introductory video, but stay tuned for additional tutorials covering things like retrofit modeling, reporting to certifications and commitments, and advancing decisions made at early design phases to subsequent phases of design. All right, well, be in touch and happy modeling. Cheers.